Oh, hey guys. Just wanted to stop in and do some homework with you guys. So, page one is reviewing division. We did really, really good on our first test. The first math monthly, the school district average was like a 57%, and our class had a 68%. So, really good job to everybody. So, when we look at these division problems, remember, we want to try to figure out what we can take out of them, right? So, for example, number one, we want to try to figure out how many 12s we can take out of this 216, right? So, we do that by doing partial products. So, using multiplication to try to chunk numbers out of the 216 until we get down to nothing left. So, I always think it's easier to start with multiplying all these numbers by 10 because 12 times 10 is very, very easy for us. So, if you put a little 10 over here and you're going to take 10 12s out of this 216, 12 times 10, we all know, is 120. So you would put 120 here, and then you're going to subtract that out of the 216. So I hope everybody understands we're taking 120 out of the 216, and that is that 12 10 times coming out, right? Or we're grouping it. Division is grouping into groups, right? So if we do our math here, we would get a 6, 96. So now we've narrowed this down. Now we need to get 12 into 96. Well, I know I can't use 10 again because 10 is 120. So that's too much. So this is where it gets tricky. This, for everybody that's watching, is where I think most people are confused. Once you've taken the 10 out, now you're always trying to figure out how much this goes into this. So now it would be how much this goes into this. So this one, you kind of just have to use your multiplication facts, keep skip counting. In your mind, you have to be able to make an estimate. We know it's less than 10, right? Because 10 is 120. So if we do 120, 11 would still be over 100, right? Because we'd be taking 12 away from the 120. So it's probably close to 8, I would guess. So if we put an 8 here, you would then take the 8 times this 2 is a 16, put it right here, carry the 1, which is really a 10, into the tens place, right? And now this 8 times this 1 right here, which is really a 10. So 8 times 10 is 80, plus this 1 right here would be 96. And then when we get to the 0, there is such thing as remainders, but when we get to a 0 like that, that's when we know we have our answer. And your answer then is just adding these two together, and your answer is 18. Got it? So for number 2, we've been trying to work on with this homework getting a little more aggressive because you can just keep taking 10s out every time, right? But when I look at this 31 into this 682, I feel like if I double 31, it would be 62. And then if I multiply that by 10, that would be 620. So I could take out a 10, which would be 310. But if I know I double the 310, or if I double the 31 and I get 620, that definitely could come out of this 682 that is right here, right? So instead of doing it times 10 like I did in this problem, I'm going to do it times 20. And I know this is the part that gets a little confusing because people go, oh, 31 times 20, it's hard. But really, it's just this 2 times the 31, which is the 64. Now I got to make sure I'm saying this right. I'm confusing myself. Which is the 62, right? 31 and 31, 62 with a 0 at the end. So it'd be 620. So I just am taking 20 31s out of this 682. So you just pick random whole numbers that would take out chunks. So now if I subtract this, I would have 2 and 6. Now I'd be down to 62. And I hope that you guys can see this 31 goes into this 62 2 times. 2 times 31 is 62. And you have nothing left. So you would have your answer up here at the top of 22. Got it? Now, if you parents are at home want to teach these children how to do the standard algorithm the way we all did it, going across, taking it out, we talked about that a little. It's a little confusing to them based on how they've been taught math. But we're just working on taking chunks out, those factors, the multiplication factors, chunking the numbers out. So when I look over at number 3, I see this 21, and I know it's got to go into 900. So if I just take a 10 out every time, that's 210 minus 210 minus 200. You can totally do that. But we're now to the stage where we should know that the 10s come out. So we got to try to think how many times we can get this 21 into 900. Or I like to tell them, try to figure out how many times roughly you can double this 21, keep doubling the 21, keep adding 20, not doubling it, keep adding the 21 to it, how many times it takes to get close to 900. Well, we all know 4. If I multiplied this by 4, that would be 84, right? 21 times 4 would be 84. So if I do it times 4, remember it's really a 40 because we're going to the hundreds. So 21 40 times is just 4 times 21, which is 408, or which is 840 with the 0 at the end. Now, you could take out a 10, you could take out a 20. You could listen, if you wanted to, you could minus 21 over and over and over and over again, and then count how many times you took it out, and that would be your answer, right? We need to, this is about the thinking process, right? What can we take out to get it to work? So if I take this out, that would leave me with 105. Now, we talk about it all the time. Now, remember, this is where we get lost for everybody watching. Now, you've taken this 840 out of this 945. So there's only 105 left. So we got to figure out how many times this 21 goes into the 105 that's down here. So I know that 20 times 5 is 100. So 21 times 5 is probably 105. And remember, we talked about this. If you pick a number that's too small, there'll just still be something left. Like if I, for example, if I picked 4 here, well, then I would have 4, I would have 81, I would subtract, I would get 1, I'd have 21 left, and I'd go, oh, darn. Then I've got to go 21 into this with a 1. So no matter, you can't really mess up. If you go over and the number's too big, then you know you've got to go smaller, right? So the answer to this would be these numbers added together, which is 45. All right, a couple more. We're going to go a little quicker. So 22, I'm just going to go by 10. Because I know if I double this, I'd be in the 400s, right? If I go, 2 times 22 would be 44 with the 0 at the end be 440. So I'm just going to take out 10, 6 and a 6. 22 into 66 is 3. 3 times 2 is 6. 3 times 2 is 6. Nothing left over. My answer is 13. Same thing for number 5. I can see that going times 10 is going to give me a number in the 400s. So that's probably pretty close. 430, subtract 6, regroup 8. Now 43 into 86. I can double 43 and know that that's 2. 2 times this 3 is 6. 2 times this 4 is 8. That leaves us with 0 at the end. You would add these 2 and get 12. So that's how I want you guys to do these. Practice the rest of them on your own. Okay, multiplication. Now, we've talked about a lot of different ways to do multiplication. I don't care what you pick. We have done the standard algorithm for this, but we have used area models. We've used the partial product. So I'm going to show you one of each strategy. I don't care which one you do. I don't care if you can magically do it in your head. From now on, you do what works for you. I'm showing you different ways you can try to do it. So I'm going to break up my first example for number 1, and I'm going to do it by breaking down the numbers and multiplying them and seeing if we can get it. So if I look at 281 by 24, I'm going to take out this 200 right here and say 200 times this 2 right here, which is 20. Then I'm going to pull out this 80 right here and multiply it by the same 20. Then I'm going to pull out this 1 and multiply it by the 20. Got it? So now I've done 281 times 20, right? And if I multiply these out, I would get 4,000. I would get 1,600, and I would get 20. So now I've done the 20, right? So if I've done the 20, I still have to do the 4. So, whoops. Now I'm going to take out 200 times 4, which is OMG, which is 800. Then I'm going to take out the 80 times the 4, which is 320. And then I'm going to take out the 1 times the 4, which is 4. And if I add all these together, I will get the answer, which is 4, 4, 17. Oh, my 4 didn't get complete over there. Carry the 1 and a 6. Personally, a lot of chances for mistakes with this, right? If you don't break up the 281 correctly and the 24, if you don't match up the 200 plus the 20, the 200 plus the 4, you could leave one of them out. If you leave out one, in fact, when I did this the first time, I accidentally went like this. I put a 24 down here instead of a 4, and I got the wrong answer the first time. So if you don't understand how to do the standard algorithm, it's still okay to do this. It's a lot of steps, though. It's a lot of things to keep organized. And you know where on our Math Monthly test that I see the most mistakes is lining up these and keeping them in order, because if they get slid over just a little bit, you're not going to get the right answer, right? Okay, so for number 2, this is really kind of the same thing, but we also use our area model boxes. So this would be breaking these numbers up and putting them in a box. So I'm going to put the 70 and the 5 over here for this 75. And then I break it up, and I'm going to break it up into 3 more categories. Now I'm going to break up the 184, 184. And now you just multiply and put your answers in the box. So 100 times 70 is 7,000. And you guys, I just hope you guys know that it's 7 times 1 and you just count the zeros, right? 100 times 5 is 5 with the 2 zeros. 80 times 70 is 56 with 2 zeros. 80 times this 5 down here is 40 with 2 zeros, or 40 with 1 0, 1 0, sorry. The 4 and the 70 is 28 plus 1 0, and the 4 and the 5 is 20. Now, we get the same problem that we had over here with this one, is now you've got to bring these out and line them up. 7,000, 5,600, 280, 500, 400, and two. Oh, see, all right. See how quick I'm an expert at this, and I just messed up. And a 20. And then add them all together to get 0, 8, 13. So this is a little more organized. I feel like you won't leave numbers out like you will. Oops. I feel like this, I feel like you have a chance to leave a lot of numbers out. This, at least I feel like you can see it and you can see the numbers. And as long as you're making sure you keep your place values lined up when you do this and you don't put them off just even by one spot, you'll be fine. But our goal and our main strategy that we practiced this whole unit was just doing the standard algorithm, which is just the multiplication like everyone has been taught for their whole life. It takes a little less thinking out of it, but if you can do it with the other strategies, you really understand what the numbers mean, what each part of the number means. So the good old-fashioned way, here we go. Let me change this to red. So 2 times 2 is 4. 2 times 8 is 16, regroup. 2 times 5 is 10, plus the 1 up here is 11, regroup. 2 times 1 is 2, plus this 1 up here is 3. So now the 2 is done. We did the 2. So remember, the 1's place is done, so you've got to put a placeholder in here. Got it? Now that I've written all over this and I can't see, let's go to the next category. So our next line I'm going to make pink. So now it's 3 times 2, which is 6. 3 times 8 is 24. Carry the 2. 5 times 3 is 15. Plus 2 is 17. Regroup the 1. 3 times 1 is 3. Plus 1 more is 4. And now we would add these up, and we would get 4 times the x means nothing. You can put a 0, whatever you want to put. I put the x in there so I can just remember that I didn't do anything to get that. It's just a placeholder, but a 0 works fine too. 4, 6 plus 6 is 12. Carry the 1, 4, 5, 6. 7 plus 3 is 10. Carry the 1, 5. One of the biggest mistakes on our monthly, which we did really good on with the multiplication and division, we're really good at multiplying and dividing. What we have a problem is we forget to add that. We forget to add that. We don't line these up. We forget this x, and then this all gets pushed over, and we add it up wrong. So we're making, like, I hate to say it out loud, this math problem right here was second grade. So we're making a lot of second grade mistakes. All right, try the rest of those on your own. Let's go to the fractions. I have to apologize in advance. I didn't realize when I pulled these ones up that they were going to be as challenging as they are. But let's do a few of them together. We know when we see these fractions and we're going to add, we have to have a common denominator. Now, I set these up for the common denominators to be a little harder, but it got a little crazy. So you guys are really going to have to think to get these common denominators. So we know we're good with our whole numbers, which are the 3 and the 4, right? So they're good. So we're just going to leave those. Now, we need to look at this 6 and this 22. We need that to be the same number. So we need the lowest common denominator. So we know it can't be less than 22, right? Because no number goes into 22 that's less than it equally. So we would start with 22. So we have to ask ourselves, does 6 go into 22? And the answer is no. So now you need to think, what's the next number that 22 goes into equally? So you have to double 22, which is 44. Does 22 go into, or does 6 go into 44 equally? And the answer, again, is no. So now we need to take 44 plus 22 to see the next, which is times 3, right? This is why our multiplication facts for third grade are very important, right? 22 times 3 is 66. Now, does 6 go into 66? Obviously, 11 times 6 is that. So our common denominator for this problem would be 66. So we're going to put 66 on the bottom of both of these fractions. Now, if you do something to the bottom to get to 66, you have to do it to the top, right? So this is 22 times 3 equals 66, right? So if we did it there, I now need to do it up here. 9 times 3 is 27. So this fraction turns into 27/66. This obviously is 6 times 11 is 66. If I did it there, I now need to do it to the top, which would give me 55 up here. Now's when you got to go slow and you really got to pay attention, because this is kind of the part that we talked about the last couple days that you guys might not be that prepared for. Now we can add these, right? The denominator stays the same. If we add 55 and 27 together, you'll get 82. We've said this before. This is like a division problem, right? This 66 goes into the 82. So because this is a fraction, remember, fractions are pieces of a whole, right? But if that numerator on the top is bigger than the denominator on the bottom, if we can put the 66, the bottom number, into the top number, that means there's one whole in there, right? It's an improper fraction. We haven't even talked about that. We will. That means you need to reduce it out, right? So simply to reduce it, you're just going to put the 66 into the 82. We know that goes one time, right? Take the 66 and let's see what's left. You've got 16 left over, right? So this fraction would turn into 1 with 16 pieces of the 66 still left over. Got it? Now, the only thing we didn't add into this yet are those whole numbers, right? So 4 plus 3 is 7. 7 plus this 1 right here would be 8. Our answer would be 8. and 16 66. Now, what we have talked about, but with much smaller numbers, is reducing these fractions to their simplest terms, right? So we know if we see two even numbers, a 2 always goes into it, right? You can always just keep dividing 2's into them until there's nothing left, and it'll almost always work, almost always. So if I divide 2 into the 16 and to reduce, and 2 into the bottom, remember, whatever you do to one side, one top or bottom, you have to do to the other. My answer would stay 8. That doesn't change. 16 divided by 2 is 8, and 66 divided by 2 is 33. That would be your final answer. So a lot of steps, you have to think through the process. But ultimately, there aren't, for our class, for our fifth graders, for our smart kids, there aren't a lot of hard math problems here. There are just a lot of thinking through what the numbers mean, right? What they mean, where they go, where we have to add them. All right, we'll do one more slow, and I'm going to do the other two quick for you to see, and then you'll have a couple left to practice on your own. So we have our whole numbers 3 and 7. They're good. 14 and 6 are our denominators. The numbers on the bottom, denominators. We need to find a common denominator. 6 does not go into 14, so 14 does not work. Remember, it can't be less than the biggest number. So you can't be, you can't say 8. 14 doesn't go into 8. You have to start, you start with the biggest number you see on the denominator to find it. So if we double 14, that's 28. 6 does not go into 28. So we're getting into trouble here. If we then triple the bottom number or add another 14 to the 28, we get 42. 6 does go into 42. So we're going to do our fractions first, 42 and 42. To get the 42 on the bottom, 6 times 7 got us to that 42. So if I do it on the bottom, I have to do it on the top. That gets me to 35. Sorry, I just cracked my knuckles. That was horrible. 14 times 3 is 42. If I do it on the bottom, I have to do it on the top. 9 times 3 is 27. So now I have my two fractions that I can add. I have a common denominator of 42. And if I add 27 plus 35, that's 62. Whoops, that's not a 2. The numerator is bigger than the denominator. That means I have an improper fraction where it's more than 1, right? So I've got to put the 42 into the 62. It goes one whole time, and I still have 20 left over. So this would turn into 1 with 20 pieces left of the 42. Everybody agree? Now, I still have to add these in. 7 plus 3 is 10. So 10 plus this 1 is 11. That worked out easy. Now I have to see if I can reduce this. If I put a 2 into both of those, that would give me 10. 2 into 42 is 21 times, and that would be your answer. So once again, a lot of steps, but it's all multiplication and division facts that we learned in 3rd and 4th grade, right? And now it's about putting them together and making them work for us. I mean, even this division problem, I mean, it's not hard. It's really actually just a subtraction problem, right? Okay, quickly, let's look at number 3. My common denominator, if you want to do it on your own and then pause and watch the video, now would be a time to pause. Okay, so for this one, our common denominator is 30. So if we do, the bottom was times 3, this would be times 3, 21. This was times 2. This would be times 2, so that would be 14. Now I can add them together. 30 doesn't change. Adding them together gives me 35. This 35, or this 30 goes into the 35 one whole time. Pen's not working. One whole time. 35 minus 30 is 5. There's 5 left over, and your denominator does not change. Now I have to add that to what is over here. 4 plus 1 is 5, plus this one is 6, and 5/30ths. Now I need to figure out, does the 5/30ths reduce? Well, 5 goes into 5 and 5 goes into 30. So I can divide them by 5. And your final answer would be 6 and 1/6. A lot of moving pieces. If this is very hard, this is one step above the hardest problems we'll see on your test. So if you can take your time and work through this, you're going to be way ahead. This is tough. I'm not going to lie to you. I didn't realize that they were going to come where we had to regroup the fractions over. That is something we just started talking about. All right, last one. Pause it and do number 4. Okay, your common denominator is 30. Remember, if you pick a denominator that's too high, it'll eventually still work out. You're just going to make the numbers a lot harder to work with. So if I multiplied the bottom, the 6, to get to 30, that was 5. So I have to multiply by 5 up here, which is 25. This went in 3 times, so that would be 21. If I then add them together with my common denominator stays the same, add them together, it's 46. This 30 goes into the 46 one time. 46 takes away this 30 would give me 16, with 30 still as the denominator. I now need to add that to the whole numbers that I have over here. 5 plus 4 is 9, plus this 1 would be 10. You keep the 16/30ths. 2 goes into both of the 16 and 30, right? So I can reduce it. And here's the thing. I told you guys. Hold on, let me finish this, then I'll tell you. If I divide them by 2, it would be 8/15ths, dividing a 2 into both of these. Now, on your test, you saw it today in class, or depending on when you're watching this video, Friday. They had a problem on there where they showed you this was the choice that was on the paper, right? They also could put this. So you might do all the work and think this is the answer, but then they might reduce it to this. You might hurry up and reduce it to this and then not see the answer, but then they might have this on there. So you need to, that's why it's important to always reduce it and have both of those numbers there. Just so we're clear, these two numbers that I nicely circled so you can't see anymore, 10 and 16/30ths and 10 and 8/15ths is the same amount. It's the same size. It's the same thing, right? So they can give you either answer. That's the tricky part. All right, try the rest of those on your own. Let me know if you have questions. Let's go to the subtraction. Now, the subtraction is basically the same thing, except, you know, before when we went, we had an improper fraction and we had like 1 left over and we were adding it over. Now we have a problem. Now we're basically taking it away and adding it back to the fraction to be able to do the subtraction. I'll show you what I mean. So number 1, we'll go a little slower here with number 1. 3 minus 2 we can do, the whole number, so we're good. We need to subtract, we need a common denominator. So 18 and 4. 4 does not go into 18. So 18 can't work. Cannot be less than 18. 18 is the biggest number. Can't be less than the biggest number. So if we double 18, we get to 36. 4 does go into 36. So 36 is our common denominator. Down here, we multiplied by 9 to get that. So we would have to multiply by 9 up here to get 27. Up here, we multiplied by 2. So we'd have to multiply by 2 up here to get 26. Just changing these fractions. So we've changed this whole thing now. So technically, our problem is now 3 and 26/36. A lot of this is organization, right? You got to keep yourself organized. Here's the problem with this now. If you have this 26 and this 27, you have 26 of something. Can you take away 27? The answer to that is no, right? So this is actually what we're talking about on Monday and Tuesday. So you guys really don't know how to do this. So that's why the point of this video. We now need to come over and basically borrow from this 3. So we would take a whole out of this, and that would leave us with 2 wholes, right? There'd still be 2 left. So we're going to take one of whatever it is we have and move it over to the fraction. To do that, we're going to take the 1 whole and break it up into the amount of pieces we have in the denominator, which is 36, right? So we're going to add 36 to the top. Now, remember, this problem is separate right here, right? We took this 2 from the top. We keep it up there. So we're going to take that whole and break it up into basically 36 36s. The denominator's the same, so we can keep it that way. Let me move this out of the way so we don't get confused. 36 will stay the same on the bottom because you don't add those, right? And then you would have to add the top, and you would get, let me see here, 6 plus 6 is 62. So now you need to slide this over. None of this changes, right? 27 36, right? Your denominator stays the same in your answer, which is 36. Now you would just do 62 minus 27, which you can do right here. You can just cross this out. That makes that a 12. 12 minus 7 is 5. That would make this a 5. 5 minus 2 is 3. And that would be your answer. So the big, and then you have 2 minus 2 over here is 0, so there'd be nothing left. Some of these don't work out that way. All right, let's look at number 6. The common denominator for number 6. I know a lot of you are thinking, ooh, 60, but that's not true. It's 30. Remember, start at the 10. 6 does not go into the 10. Double the 10, 20. 6 does not go into the 20. Triple the 10, 30. 6 goes into the 30. Keep doubling that number on the bottom, or keep adding that number to it until you find the one that it all goes into. So the common denominator that we're looking for is 30 on both of these. This was times 3, so this would be times 3, 27. This was times 5, so this will be times 5, which is a 5. Here's our problem. 5, I'm going to highlight it so you can see it. This 5 can't be subtracted from this 27. Or you can't take 27 away from the 5, right? So what do? We got to go over and break up this 6 and take that whole, and we're going to make it match the denominator, which is 30. So it would be like adding 30 30ths over here, which would give us 35 30ths. Now, you don't have to keep rewriting all these if you can see this. So now you have your common denominator is 30. We've got that, so you can put it down here in your answer. We know we're good with that. Then you got to do 35 minus this 27, which is what? 8. Now you've got to think, can I reduce that fraction? Well, they're both even numbers, so we know we can do it too, minimum. 4/15. So I know this is a little tricky. This is going to be new for us next week. It might be a little hard on your homework, but if you're following along with me, 5th grade is all about the thinking process, right? Okay, I'm going to do the last two a little bit quicker because I don't want to run out of time on my video. We got the 5 and 2. They're good. We can subtract that. 8 and 12, we need to find the common denominator. 8 does not go into 12. So now we need to double the 12. 12 plus 12 is 24. 8 does go into 24, so our common denominator would be 24. This is times 2, times 2. This would be times 3, times 3. That would give us a 3 on top. It would give us a 22 down here. Same problem. 3 minus 22 we cannot do. Now, here's a little twist. We're going to borrow this 5. Don't forget, we still have 4 minus 2 over here, so we're going to have to add that into our answer later, right? So if I'm going to take one of those wholes out, I'm going to break it up into 24 pieces to make it easy. 24 24s. That would give me 27 24s. So now I can do the math, right? Essentially, what we've done is we've wiped out this. This is all our work, and I don't want you to cross this out every time. I just want you to see the visual of this. We've now just made fractions that we can subtract, right? So your denominator stays the same, 24. 27 minus 22 is 5. And now here's where we'll miss it. What are we going to forget to do? The other ones worked out to 0, but we still have 4 minus 2 over here, which is 2. 5 does not go into 24, so we can't reduce that. There's nothing else that you can divide into 5 to make it get smaller. So unless that 5 went into the denominator, the 24, we can't reduce it. Okay, last one. All right. Let's see here. The 6 and 2 is good, right? We got to find our common denominator. 6 does not go into 20. It does not work. So we'd have to double 20 to 40. 6 does not go into 40 equally. So it does not work. So I'd add 20 more. That would be 60. 6 does go into 60. So our common denominator is 60. 2, this would be times 3. So I'd have to do this times 3. 17 times 3 is 51. This would be times 10. So this would be times 10. That would be 50. I have a problem again. 50 minus 51 you can't do. So I'd have to come over here and borrow 1. That would make that a 5. I would be adding 60, 60. Now I want every, listen, that's 60, 60. You could make it whatever you want. It could be 100, 100. It could be a billion, billion. You're breaking that one whole up into the amount of pieces your denominator is, no matter what your denominator is. So don't let that confuse you. This right here still just has a value of 1. If we were talking about cookies, that would be like you took one of these cookies from over here and broke it into 60 pieces. That's all it is. Don't let the 60 throw you off. This 50, 60 right here, 50, 60th right here, that's like if you had a cookie broken up into 60 pieces and 10 of them were gone. You only had 50. So don't let that confuse you because the numbers are big. It's still just pieces of one whole, right? So if we add these up, we would have 110, 60. That's good because now our denominators match right here, right? So we know our denominator is 60. 110 minus this 51 would give us 59. And now we do our subtraction. 5 minus 2 is 3. You would have your answer. A lot of moving pieces, but remember, you're literally just, all we did in this problem was skip count by 20s here, multiply 7 times 3, skip count by 10s and multiply, skip count by 10s and multiply, add 50 and 60, subtract 110 minus 51, subtract 5 minus 2, regroup 6 down to 5, all things that we've done in second and third grade, right? The hard part is we have to put them all in order and keep this whole entire mess organized, right? That's the challenge. Try to do the last 4 on your own. So we're going to start for science a little bit of a fun thing with our homework for a while. We're going to start to do some investigations. So the main point of your investigation this week are why are bones hard and muscles soft? So you're going to read some articles, answer some questions. This is something we don't really talk about in 5th grade, but I think it's a really cool kind of research thing for you guys to do at home and to learn about some topics that you might not see until a little bit later on, and some vocabulary that's a little advanced for what we're doing, but we're doing so good with the vocabulary, I think you can handle it. So you guys are going to come in, and I know it says day 1. You can read these articles whenever you want, but you're going to read the article and then answer the questions below. Now, I don't want you to get upset, or if this is hard or tricky, this is not the end of the world. I want you to read and think about what it says. These are kind of just like questions that you can pull the answers out of the reading. So when you look at like the chart here, they give you the definitions over here. We added these to our list. It's all talked about in the article. So it says, use the vocabulary words to label the parts of the cell. Briefly describe. Now, I know the page is kind of small. You don't really have to describe. It's fine. But over here, it says cell is the basic structure of a living organism. Well, this whole thing, this whole picture is the cell, right? This is the cell. The next one says cytoplasm is the jelly-like substance inside a cell. Well, only one of these arrows is pointing to something that's inside the cell that looks like it would be jelly holding things together. And that is this area over here. So this would be the cytoplasm. Remember, we have bajillions of these cells. And just like we talk about electricity, how the electrons flow, this is the stuff that's in our body that helps our body move and survive, right? And this is how you're going to start to learn about bones. This is what makes up our bones and how they function. So the next word says cell membrane, the thin sac that surrounds the cell. Well, that's probably this right here, right? So that would be cell membrane. You can write that in. Now, nucleus is the part of the cell that directs all of its activities. Now, you might go, "Ooh, I don't know." But when you read up here, it says inside the cell, a central nucleus controls the cell's activities. So it's got to be in the center. Well, number one, we only have one left. And number two, this is pointing to the center where the nucleus would be. The center is in the middle. So that would be the nucleus, which I'm spelling wrong now. So go through and try to answer these questions. Think about what it asks. The next one says, what do you think the function of muscle cells is? What do you think the function of the bones? Well, muscles help us move. Muscles are what attach our bones together and make them move, right? Bones give us, if your bones just went away, you would just go right down to the ground, right? So then when you go to the next page, read more information on muscle tissues, how it works, more information to answer your question. For example, your kneecaps, it says mostly, here is the connective tissue or muscle tissue. Hopefully by the time you're watching this, you've read this. I'm not going to read it to you. You can read it yourself. But what kind of tissue do you think these are made up of? Well, your kneecaps would be connective because your kneecaps connect your thighs and your lower leg, right? If you didn't have a kneecap, wouldn't your leg fall off or your leg would be stuck straight, right? For example, another one, your heart. I know it seems weird, but your heart is a muscle. In fact, it's probably your most important muscle. So go through. You're allowed to use the internet. You're allowed to research these. Take a look at the next page. We have some, they want you to rewrite. Some of these sentences are a little tricky, but if you look up in here, as you're reading in here, you'll find your answers. They change some of these words. Like, for example, it says the muscle tissue in your heart is made up of long, thin cells. That's not true. It's in the skeleton. And if you go, "Oh, Mr. Conklin, how did you know that?" I'm not really sure. The skeletal muscle tissue is made up of long, thin cells that look like threads. So you got to find the word in there that they made wrong, that they switched. The last one, voluntary and involuntary. Good examples of those. I do it constantly in this video. I'm voluntarily moving my what? Hands, neck, tongue, everything. Involuntary, things you can't control. Can you stop your heart from beating? Like just by going, "Okay, heart, stop." I suppose you can hold your breath, but eventually your lungs are going to move, right? So those are involuntary, things that happen on blinking happens involuntarily, right? So go through and read through all the days with all the information. This is some vocabulary, some labeling down here. Don't let this labeling down at the bottom kill you really, really hard. Once again, it's the same thing, right? Inside the cells is the nucleus. The little gel that holds it all together is the cytoplasm. And the outsides that go around the outside is the cell membrane. And it's the same thing for this one, so you can label those. Now, here's where you get the extra credit. You can watch YouTube videos. There are tons of them that talk about this. You can use your research. On this page, it's half a page, half a little notebook page. I don't care if you draw pictures and diagram it. I don't care if you write how they're different. But this is where you get your bonus extra credit. This is our extra credit for science. Tell me why bones are hard and muscles are soft, what their purposes are, how they work. I don't care how you do it. You can staple a paper to this. You can print out information on it, whatever you want. But with your homework, answer this question and you get bonus points for how creative and how well you do it. If you just go, bones are hard to keep your body together and muscles are soft so they help you move, I'll give you 2 bonus points maybe. But if you really get into it and think about how you could present this to pretend you're talking to somebody that has no idea. And if you can do that, you can get up to 10 points. And if it's really crazy, sometimes I get nuts and I give a lot of points. So the last 2 pages are just on traits. The traits that are acquired or inherited. Read the articles. I'll tell you right now, these questions are like, well, baby simple, so I'm not giving you the answers to them. But it's important that you read these because some of these could come up. They're important things for us to know for our end of the year test and just important things that will help you when you get into middle school and you start taking biology classes and things. These are things that we don't really get to in elementary school that much, but I want you guys to see. So make sure to read the article, answer those questions, and it is worth the points. So if you guys have any questions, let me know. You can send me an email on Canvas, or let me know in class if you have any questions.